So the equations are probably the on the more difficult side, I would think. But there's a simple rule that will help us with the equations. And that simple rule is this: if anything funky is happening to y, it's probably not a function. So if we look at this first one, we have y equals 3x plus 4. If I was to graph that, it would be a straight line. It's linear, so it's only going to be be hit by a vertical line in one spot. So yes, a would be a function. And again, our rule is going to be basically, and I'll talk a little bit more in detail as we go to each equation, if nothing funky is happening to y, like it's being cubed or something weird like that is happening, it's probably not going to be a function if something funky is happening to y. So let's take a look at this next one. We see we have y squared, or y to the power of 2. And so y to the power of 2, let me pull up something real quick here. What we got is we have y squared. You can hear Lindell in the background there. Y squared equals 4x plus 7. And you can see that this would not pass the vertical line test. If I was to draw a vertical line on the right, I would run into the graph in more than one spot. All right, had to pause for a moment. Lindell wanted to chat me up for a second. So let's see. Yep, I'm recording again. Great. Okay. So if we look at this next one, we have a y squared. And like I was saying a second ago, before Mr. Lindell, this is what something that has y squared looks like. And so again, if something funky is happening to y, most of the time it's not going to be a function. So we can say for sure this one is not a function because it's a y squared. So we'll talk about an instance where there is only one case where something funky could be happening to y and it would still be a function. But let's just pound through these. And so we've got a right here, y equals 3x. That looks normal. Nothing funky is happening to y. So yes, that's a function. And number 4, again, look at y. Nothing funky is happening to y. So yes, that's a function. Next, nothing funky happening to y. So yes, that's a function. And again, next, nothing funky is happening to y. So yes, it's a function. Alrighty, let's take a look at the only instance, at the only instance where you could have something funky happening to y and it would still be a function. So if you have y, but it has an exponent that is an odd number, and this is kind of a weird thing to try to remember. I usually forget it, honestly. But let's graph this. So we've got y to the power of 3 equals 2x plus 6. You'll notice that even though it looks kind of close right there that I might be hitting a bunch of points if I zoom way in, the line actually never gets vertical. It has a tiny bit of a slant to the right to it. So this is what y to the power of 3 looks like. And you can see that I would not hit in more than one spot if I drew vertical lines. And so if that exponent on y is an odd number, it's a function. If it's an even number, like we did 2 earlier, not a function. Not super important that you remember that. The odds of that coming up on a test are really pretty small. But for those of you that have a great memory, something to tuck away. Okay, so capping this one off again, guys, if the exponent on y is odd, it is a function. If it is even, it is not a function. Kind of a weird rule, but for the most part, if something weird or funky is happening to y, it is not a function. And so lastly, we have y equals the absolute value of x. Again, nothing funky is happening to y, so yes, that is a function. And I think, oh, we do have two more. Okay. So here we have a y cubed, and again, if something funky is happening to y, most of the time it's not going to be a function. But if this exponent right here is odd, then it is going to be a function. So yes, this is a function. And like we saw earlier, it would look something like that. Okay. And then down here, nothing funky is happening to y. So obviously, it's a function. That's it for this video. I hope this was helpful.